Okay, welcome to 1.8, other types of inequalities. So we are looking at different types of inequalities here, and in 1.7 we did linear inequalities. And here we're going to be looking at different types of inequalities. So one thing that we should remember is our end behavior. And our end behavior, we know that we look at the leading coefficient and the degree. That's going to help us with the end behavior. So we're going to say if the degree is odd, we know it's going to be going in the opposite direction. If the degree is even, it will be going in the same direction. Then if we first look at the leading coefficient, we're going to say if it's positive or if it is negative. Okay, so this is going to tell us the right side of the end behavior. So if the leading coefficient is positive, then that means that the right side will be going up. If the leading coefficient, the first number in front of the variable with the highest degree, if that is negative, that means that the right side will be going down. And then from there, you could say what the left side is doing, because if it's an odd degree, it goes in the opposite direction, even degree, same direction. So we want to keep this in mind as we're doing these. Okay, so here we go. We're looking at polynomial inequalities. So we're going to start out with a quadratic. So this is saying we want to know, when is this quadratic less than 0? Meaning, when will this be underneath the x-axis, right? If we're talking about when is it less, oh, how's that line, huh? When it's less than 0, we want to be looking at, it's a little bit better. We want to look at when is it less than 0 or underneath the x-axis, because where your y value is negative. Okay? So what we want to be looking at is our critical values. Okay? The critical values, or the critical numbers, we're going to find by factoring this. And here if we factor this, I get x minus 3 and an x plus 1. Okay, and I'm going to just set this equal to 0 here to find the critical numbers. So I get x is 3 and x is negative 1. That is telling me where it crosses my x-axis. So I have x is 3, 1, 2, 3, and I have x is negative 1 right here. We know that this is my y-intercept, so if I graph this, here's my y-intercept. I can find the vertex, but I really don't need to right now. I just need to know what this looks like. I know that the value of a is 1 here, it's positive, therefore my quadratic is facing up, and it's an even degree. So it's going to look something like this. Okay, so if we look here, we want to know where it's less than 0. So if we can graph it, awesome, then you don't have to plug any values in, because you could just simply look at this and you can say, okay, where does it look like this graph is less than 0, meaning underneath your x value, your x-axis? All of this here, right? All of that is less than 0. So therefore, if that's where it's less than 0, we just look at the interval. This was negative 1. This was 3. Therefore, my answer will be from negative 1 to 3. Since it's just less than, then therefore I am not including negative 1 or 3. So this is my answer, negative 1 to 3, not including them. That's why we use the parentheses. If it was less than or equal to, we would use brackets, and it would tell us that we are including the critical values. Okay, I'm going to explain the next quadratic one in a different way, where if we do not graph the quadratic, then what do we do? Okay, this is just a slide for you guys to take some notes on. This is telling you how to find the test intervals. So you guys can read through this, pause it now, write down the steps for it if you didn't already write them down. Okay. Okay, solving a polynomial inequality. So here we go, another quadratic that we have. So we're going to, again, factor it at first to find our critical values. We say what multiplies to -6 and adds up to a -1. That's going to be x minus 3 and x plus 2. -3 plus 2, -1. -3 times 2 is a -6. We find our critical values and we get x is 3 and x is -2. So, from the notes that you just took down with finding the intervals, we are going to write these in order from least to greatest. -2, 3. We're also going to include -infinity and infinity. So, this is going to help me with my test intervals. So here are my intervals. Those will be from -infinity to -2, from -2 to 3, and from 3 to infinity. Okay, so now what I'm going to do is I'm going to pick an x value that is in that interval. So if I pick a value in this interval, I'll pick -3 here. In this one, the easiest one would be 0. And in this one, 4. And then I'm going to plug it into my quadratic, x squared minus x minus 6. And I'm going to say if it is positive or negative. In this case, we want it to be less than 0. So therefore, we want it to be negative. Because less than 0 is negative, right? So if it comes out to be negative, then it will satisfy this inequality and that will be part of our solution. So here we go, plugging in -3, we have -3 squared minus a -3 minus 6. This is a 9 plus 3 minus 6. 9 plus 3 is a 12, and 12 minus 6, 12 minus 6 is 6. Okay, so that is a 6, and therefore this is positive. So we don't want positive values. That one is not going to work. Moving on to plugging in a 0. We'll plug in 0 here. 0 minus 0 minus 6 is a -6, and that one came out to be negative. So this one is part of our solution. We'll see here if this one works. Plugging in 4. 4 squared minus 4 minus 6. That is a 16 minus 4 minus 6 for a total of a positive 6 here. That one is positive. We don't want it to be positive. So therefore, our only solution here is from -2 to 3. Since it's just less than or equal, since it's just less than 0, we are not including either of our critical values, so therefore we use parentheses. Next, we're moving on to cubics. Okay, so first we're going to get everything to one side. So here we go. Then we're going to notice that it's saying, so I'm adding 48 here, greater than 0, meaning we want it to be positive. In the end, our end result will be positive, meaning above your x-axis. So we first are going to start by factoring this. So we're going to factor out our cubic. So here we go. We can look at the first two terms and say, what can I take out? An x squared. And I'm left with a 2x minus 3 here. We know that we need to have the same binomial left over here. So I'm going to be left with a 2x minus 3 here. And in order to have that left, I need to take out a -16. You can check that by dividing each term by -16, and you'll get this binomial. setting it equal to 0 so we can find the critical values. For this, we took out, if we take out a 2x minus 3 from both of these, I'll be left with an x squared minus 16 here. X squared minus 16. We can actually factor this a little bit more using the difference of two squares. Therefore, x squared minus 16 becomes x plus 4 and x minus 4. And now I can find my critical values. So therefore we get x equals 3 over 2, or 1.5. X equals negative 4, and x equals 4. So therefore we have three critical values. Writing them in order from least to greatest, I'll have negative 4, 3 over 2, and 4. And then we want to also include negative infinity and infinity. So for some of you, it might be helpful to write this out on a number line. Oh my goodness, that is terrible, huh? We are gonna write this out on, it's just really hard to write with this pen. Okay, this is my straight number line here. I'm gonna write this out. Here's 0, 1, 2, 3, 4. Here's negative 4. Here's 1 and 2. So here's my negative 4. Here's my 1.5. Because 3 over 2 is 1.5. Here's my 4. Alright. So, when we're looking at this, we want to see, okay, it's either in this part here, which is going to be from negative infinity to negative 4. That will be a test interval. The next one will be from negative 4 to 3 over 2, or 1.5. Okay. The next one will be from 1.5 or 3 over 2 all the way to 4. And then the last one will be from 4 to positive infinity. Okay, so this should also help you determine what x values to test for. So I'm going to write my intervals down. Intervals, here we go. So from negative infinity to negative 4, from negative 4 to 3 over 2, from 3 over 2 to 4, and our last one, 4 to positive infinity. Okay, so now we're going to choose x values to plug in. So you can look at your number line if that's helpful. To the left, or in this black region, we could pick negative 5. For negative 4 to 3 halves in this red region, we could pick 0. From 1.5 to 4, we could pick 2. And from 4 to infinity, we can pick 5. Okay, so now we're going to write down what the cubic equation was. So we have a 2x cubed minus 3x squared minus 32x plus 48. And then we're going to say if it's positive or negative or not, and we want it to be positive in order to satisfy this inequality. Okay, so here we go. We got 2 times negative 5 cubed minus 3 times negative 5 squared minus 32 times negative 5 plus 48. So negative 5 cubed is a negative 125. That's going to be a negative 250. This is a negative 3 times 25, which is a negative 75. This is going to be a plus 160 and plus a 48. Okay, putting that in my calculator so I don't get it wrong. Negative 250 minus 75 plus 160 and plus 48 is negative 117, which came out to be negative. We don't want it to be negative though. We want it to be positive, greater than 0. So that one is not included. Nope. We plug in 0. This one's always nice because it's just 0, 0, 0, 48. Okay, let me just, there we go. Okay, 48. That is positive. So therefore this will be, oh my goodness. This will be included in the interval. This is one of our intervals because it's positive. Okay, the next one here, we're going to plug in 2. Okay, so we plug in 2 here. We get 2 times 2 cubed minus 3 times 2 squared minus 32 times 2 plus 48. This is 8 times 2, which is a 16, minus 4 times 3, 12, minus a 64, plus 48. This will be 4, minus 64 is a negative 60, plus 48 is a negative 12. That came out to be negative, so that is not going to be part of our solution because it's negative. And then finally we plug in 5 for our last interval. So we plug in 5 here. We have 2 times 5 cubed minus 3 times 5 squared minus 32 times 5 plus 48. That is a 125 times 2 is a 250. 25 times 3, negative 75, minus 160, plus 48. That will be a positive number. I think that's 63. Let me check. 250 minus 75, minus 160, plus 48, 63. It's always good to check though. That's a positive number. So that will be another one that will be part of our interval. There we go. So that means our interval will include both of these here. And therefore, when we write our answer, we can write the union of it. This is not including either of our critical values. So therefore, I'm just going to write it as parentheses negative 4 to 3 over 2, parentheses union, parentheses 4 to infinity. And that is my solution. Okay, moving on. Unusual solution sets. So what we're looking at here is, if you notice that if we were going to graph this, we should be able to realize by now that this is going to be entirely above my x-axis. It's entirely above my x-axis. If I find the vertex, x equals negative b over 2a, x equals negative b over 2a, negative 1, and then I plug negative 1 in here, I get 1 minus 2 plus 4. Negative 1 plus 4 is a 3. So negative 1, 3 is my vertex. Negative 1, 3 is up here, and it's facing up. So this is entirely above my x-axis. And this wants to know, where is it greater than 0? Meaning, where is it positive or above your x-axis? Everything is above your x-axis. So therefore, my solution here is going to include everything. So I'll just write that as negative infinity to infinity. That's my answer. Okay, getting better at this boxing my answers thing. Okay, there we go. X squared plus 2x plus 1, if we look at this one here, we can actually factor this one. But when you actually factor this one, you'll see that I'll get x plus 1 times x plus 1. If I find my critical values, I get x equals a negative 1. 1 times 1 is 1. 1 plus 1 is 2. And therefore, this means that my vertex is going to be on the x-axis. It's facing up. So therefore, you can go ahead and plug this in if you'd like. You get 1 minus, I'm just plugging negative 1 into here, minus 2 plus 1. That's going to be a 0. And that's because it's on your x-axis. If you get the same number twice, it's going to be your vertex on the x-axis. Okay, so this means it wants to know, where is it less than or equal to 0? Well, the only number that's equal to 0, there's no values that are less than 0, but negative 1 is equal to 0. So therefore, my solution is just this negative 1. That's my answer. Okay, the next one here, this one, if you plug this in, well, it can't be factored. So we'd have to use a quadratic formula or completing the square. And you'll end up getting an imaginary solution. So you'll see that it will be, if you get an imaginary solution, you know that it's going to be entirely above your x-axis. And this is asking, where is it less than 0, meaning where is it below? Nowhere. There's no solution. Okay? Because it's entirely above your x, and it's asking where is it below the x? It's not. No solution. D, okay, part D here, if we look at this one, then we know, again, if I go ahead and factor this here, x minus 2 is another one that has the vertex is going to be on your x-axis. So here's 2, 0, right here. It faces up with the y-intercept of 4, right? My beautiful graph there. Okay, and it wants to know, where is it greater than 0? So this entire graph is greater than 0 except for at 2. So everywhere except for 2, it's greater than 0, because at 2, it's on 0. And since it doesn't say greater than or equal to, 2 is not included in your set. So therefore, we would write this as everything from negative infinity to 2, union 2 to infinity. This just means all reals except x is not 2. But we're going to write it as an interval notation, which is this right here. Okay. Moving on, rational inequalities. Make sure we read this. X values when the numerator is equal to 0. X values when the denominator is 0. So when you set the numerator equal to 0, that's finding the x-intercepts. The denominator equal to 0, that's finding your asymptotes. So if we subtract 3 here, I have a 2x minus 7 over x minus 5. I'm going to subtract 3, put them over 1, and that's less than or equal to 0. Okay, I'm going to get a common denominator here by multiplying the top and bottom of this fraction by x minus 5. Alright, so by doing that, I'll have one fraction here. So I'll have 2x minus 7. I'm going to distribute in this negative 3 here. So I get a negative 3x plus 15 all over my common denominator of x minus 5. Okay, combining like terms, 2x minus 3x is a negative x. And then we have a negative 7 plus a 15 is 8, or 15 minus 7 is 8, all over x minus 5. This, if we were going to graph this, it would be a rational function where there's an asymptote of x equals 5 and an x-intercept of 8. Okay, so we know that if I set the numerator, like we just read in the notes, if I set the numerator equal to 0, this is going to be a critical value. This is actually finding your x-intercept of your rational graph. X is equal to 8. That's a critical value. Along with, if I set the denominator equal to 0, this is also a critical value, and this is going to be giving you the vertical asymptote. Hopefully we remember that from Algebra 2. So x minus 5 equals 0. Therefore, x equals 5 is my other critical value. Okay, so I have two critical values. Again, we're going to put them in order from least to greatest. You can draw out a number line if you would like. Okay, so we have negative infinity, 5, 8, and infinity. So writing my intervals out, I'll have negative infinity to 5, I'll have 5 to 8, and I'll have 8 to positive infinity. Okay, looks funny having an 8 and an infinity right by each other. Okay, anyways, so now we're going to test them, and keep in mind that we want to know when it is less than or equal to 0. So we want to know when is this going to be less than or equal to 0, meaning when is it going to be negative. Alright, so let's give it a go. Here we go. So from negative infinity to 5, our x value can be 0. That one's nice, right? From 5 to 8, we can plug in 6. From 8 to infinity, we can plug in 9. So let's just write this over here. Negative x plus 8 over x minus 5. Okay. So plugging this in, we have 0 plus 8 is 8 over negative 5. That is obviously negative, and you can write it out if you want, negative 1 3/5. So it's negative, and we want it to be negative. So that one is good. This is going to be part of our solution. Okay, plugging in 6, I get a negative 6 plus 8 over 6 minus 5. 8 minus 6 is 2 over 1. That's a 2. That's positive, not going to be part of our solution. Negative 9 plus 8 over 9 minus 5. That's going to be a negative 1 over 4. That is negative, also part of our solution. So here's the thing. We found the two that work, the two intervals that work. We know it is less than or equal to, correct? So therefore, we know that since we have x equals 5 is a vertical asymptote, the vertical asymptotes are never included because they're asymptotes, meaning it's not going to cross that. So we're going to write this out as negative infinity to 5. We know that whenever it has infinity, we use parentheses. Since this is an asymptote, we use parentheses. Union, then we're going to have 8 will be included. It's less than or equal to, and 8 is your x-intercept, so we are going to include 8 all the way up to infinity. Here's our solution. All right, we're getting there. So, finding the domain. This is the last slide here. Awesome. Okay, so finding the domain. We know that when we are finding the domain, we want it to be where anything underneath a square root has to be greater than or equal to 0. Hopefully we know that. So we're going to find where it is greater than or equal to 0 in a similar way. We should be able to see that we can divide everything by 4, and therefore we're left with a 16 minus x squared is greater than or equal to 0. Factoring this, I get 4 using difference of two squares. 4 plus x and 4 minus x. Setting it equal to 0 so we can find our critical values. We get x is -4 and we get x is 4. Okay, so those are our critical values. We write them from least to greatest, including our negative infinity and our infinity, positive infinity. And then we will write the test intervals. So our intervals will include negative infinity to -4, -4 to 4, and 4 to infinity. Okay, so we'll choose x values for this. So from negative infinity to -4, we can use -5. From -4 to 4, we can test 0, and for this one we can test 5. All right, and then we can plug it into the simplified version here, 16 minus x squared, and we want it to be positive, right? We want this to be positive. Beautiful handwriting there. Okay, so plugging in, we have 16 minus -5 squared. That's a 16 minus 25. That's going to be a -9. So this is negative, which is not going to satisfy our solution. Plugging in 0, 16 minus 0 is 16. Positive, that will include our answer, will be included in our answer. And 5, we have 16 minus 5 squared. 16 minus 25 is again -9, which is negative, which will not be included. The only thing we need to make sure that we're correct on is if it's parentheses or brackets. Since it is greater than or equal to, we are including those values, so therefore our solution is from -4 to 4, and that is our answer. Awesome. Thanks for listening. Hope you enjoyed it. Sorry it was a little long.